Hello guys, this is me again, Mr. Zikri speaking. In this video, I'm going to explain about force between parallel current carrying wires. In previous video, we discussed about magnetic force on a current carrying wire inside a magnetic field. Now, the force is exerted by one wire with current to another wire, also with a current flowing through it. So here is the first picture. We have two parallel current carrying wires having current I1 and I2. Now let's see how these two wires can pull each other. Now let's see if there is a current inside this wire 1. So around wire 1 there will be a magnetic field. Is that correct? Yeah. So this magnetic field created by current on wire 1 will be directed away from us on wire 2. Okay, so this is the magnetic field, and then we have current over there, current going up, current is going up like that. Applying right hand rules, so I'm going to draw this hand again for you. Now see I as a thumb, I, and then B as a magnetic field, and the direction of your palm is the force. So by following these rules, I is upward, B is directed away from us, this is your thumb, this is your forefingers, and the direction of your palm should be to the left. Okay, is that correct? So I'm going to mark this B as a B1 because this B is actually created by wire 1 on wire 2. Now let's see. The current I2 on wire 2 will create magnetic field around it, and then the magnetic field on wire 1, because of the current on wire 2, will be directed toward us or going out from the paper. So now let's see again. This is B toward us, I upward. By using right hand rules, this is I, your thumb, B, your forefingers, the direction of your palm should be to the right. So in this case, the force on two wires is pulling each other. In another case, this current having opposite direction. I1 is upward and I2 is downward. I1 will create magnetic field. Okay, this is B2. Magnetic field on wire 2, and then using right hand rule, the force will be to the right on wire 2. Now let's see on wire 1 by wire 2. This is B2. Applying right hand rule, we are having I upward, B going away from us, and F to the left. Okay, so we can memorize it easily if the current has same direction, the force on wire is attraction force. But if the current has opposite direction, the wires repel each other. How big is the force on the wire? Okay, now as you know that the force is B I L, and then because let's say this is the force on wire 2, so this is I2 L2, but the B is B1. B1 itself is mu O I1 over 2 PA, while A is the distance between two wires. This is A, this is A, and then multiplied by I2 times L2. So we have the force is mu O I1 I2 L over 2 PA. Is it clear enough? Okay, in this video I will only explain 2 slides. This is the first slide. You can pause this and then write it down, draw it on your book, and then write the notes. If you think that you have your own language to express the theory or the concept, you can do it by yourself or just copy as I did in my video. If you have done writing the note, we are going to continue to the next slide, which is an example. So here is an example. We have 2 set of wire. This is first wire straight, and then it is having current I1 upward, and then the second one we have loop, and this loop, in this loop there is a I2 current flowing inside this loop. So as we can see that if this current I2 is moving inside the loop, on the left side it will be going up, and then on the top side it will be going to the right, and then on the right side it will be going downward, and then on the bottom part it will be going to the left. So a minute. Okay, so this current I1 and I2 will affect each other. So it is given the current on I1 on the wire 1 is 5 ampere, and then wire 2 is 10 ampere, and then find the net force on the wire 1. I don't think so. It should be wire 2. So wire 2 is this one. So let's see. Okay, okay, look at this. This wire 1 and wire 2 will be affecting each other. On wire 2 left side it will have force to the left. Let's say this is A, B, C, D, and then let's say this is F, A, B, and then upward it will have force upward. I'm sorry, this is FBC, while here FCD, and then here I'm sorry, FAD. Okay, in this case FBC will equal to FAD, so they will cancel each other. So we have FAB and FCD with opposite direction. So we'll find FAB. FAB is mu O I1 I2 L over 2PA. So mu O is 4P times 10 to the power of minus 7. I1 is 5 ampere and I2 is 10 ampere. And then the length is this AB length is 0.45 meters over 2P. This is A for the first condition, let's say A1. So A1 is 0.1. Cancel, we have 2. Okay, 2 times 5, 10. 10 times 10, 100. This is 0. What is it? So we have 4.5. Times 10 to the power of minus 5 Newton. And this is FAB. To the left. And then FCD, let's calculate. FCD mu O I1 I2 L over 2P A2. Okay, mu O 4P times 10 to the power of minus 7. I1 5 times 10 times 0.45 over 2P. A2 is this, it's 0.25. So we have this. Let's 2 times this. Okay, and okay, 2 over this one is 8. Yeah, 8 times 5 is 4. 40, I mean 40 times this is how much is it? 40. Okay, it's about 1.8 times 10 to the power of minus 5 Newton. Okay, look at here. We have this. It's not finished yet. We have to calculate the total force on wire 2. So the total force should be FAB minus FCD. This is 4.5 times 10 to the power of minus 5 minus 1.8 times 10 to the power of minus 5. We have, how much is it? 2.7 times 10 to the power of minus 5 Newton to the left. Yeah. Okay, that's all for today. I hope you can write it down, and then if you have something to ask, we can discuss it inside the class. And thank you for watching.